Is historical soil phosphorus a nutrient source to our nation's rivers? Well, let's find out as we're looking at USGS. Phosphorus is an essential nutrient for plants and animals. However, excessive phosphorus in surface water can cause explosive growth of aquatic plants and algae. Now, this might not seem a problem on its own, but this can lead to a variety of water quality problems, including low dissolved oxygen concentrates, which can cause fish kills and harm other aquatic life. River connects our terrestrial landscape with downstream lakes, reservoirs, and coastal environments. High phosphorus concentrations and associated water quality degradation are a key water quality concern in many of our nation's rivers and streams. A team of USGS scientists recently published a paper that investigates the potential sources of phosphorus that contribute to degrade river quality. Here's the lead author had to say about the study. So the question was, what question were they trying to answer with a recent study? The link between agricultural excess phosphorus and excess algae growth in freshwater ecosystems is well established. Management efforts to reduce the movement of excess agricultural phosphorus to surface waters have been in place for decades, but have not seen widespread improvements in water quality. This may be the source of phosphorus leading to degraded water quality conditions may not actually be linked to the manure and fertilizer currently being applied to nearby farms and fields. Phosphorus contributions to current river water quality degradation can also come from older historical manure and fertilizer inputs that have been built upon soils. And sometimes these phosphorus sources can be more than 20 years old. So just because it's been stopped for a while doesn't necessarily mean the problem's going to go away. And they asked, what's unique about this study? Previous studies that have looked at the current historical phosphorus sources and their effects on water quality have been more limited in either space, the number of watersheds or time period of analysis. Our study looked at water quality in 143 river sites for a 20-year period of time since 1992 to 2012. Now, what did they gain from the agricultural phosphorus management? The way we elevated current agricultural phosphorus management was called agricultural phosphorus balance, defined by phosphorus inputs and outputs. Two key inputs were fertilizer and manure applications to soils, and one key watershed phosphorus is crop uptake and the removal of crop plant and harvest. So you can think about the agricultural phosphorus balance in a similar way to bank balance, based on how many dollars that you put in compared to how many you take out. If you have a deficit of zero balance or surplus, you'll call this savings. The difference between your bank balance and phosphorus balance is that you usually want a surplus in your bank account, but most conservation efforts have been trying to reduce the surplus of phosphorus in the landscape, aiming towards a zero balance. They found 7% of river sites had deficits, meaning the inputs were less than what was taken up by plants. 25% were balanced, meaning the inputs were equal to what was taken up by plants, and 68 of the river sites had surpluses as well. So what insights did they gain? They documented that historical phosphorus was a source of river phosphorus, 49 out of 143 sites, and the agricultural balances at these sites showed that older legacy phosphorus sources, probably manure and fertilizer inputs from the 1980s, were still having an effect today on river phosphorus. But the good news is, at 43 river sites where agricultural balance has decreased over time, the water quality has improved. So, as we can see, phosphorus can linger for a very long time, even historically. So it's always a good idea to properly test your water for high levels of phosphorus.